Hello, and it's time for more biology, although this is really a bit of a chemistry, organic chemistry. I never took organic chemistry. Maybe one day. It's coming. Well, the fundamental unit of life atomically is carbon. In fact, I watch Star Trek, which my daughter Sophie doesn't want to hear, but in the original Star Trek movie, way, 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 way back, they talked about carbon-based units. They were talking about humans. So yes, I'm a carbon-based unit, you're a carbon-based unit, and there's nothing we can do about it because that's just the way God did it here on this planet. We're a carbon-based unit. Or as one person put it, carbon is the star of the show. So organic molecules are molecules that are made out of carbon. There was an episode of Star Trek, which you don't want to hear, where they were made out of, I think, sulfur. Is that right? Silicon. No, they were made out of silicon. That's not important. I don't even know if that's possible. But we're made out of carbon, and that's plants, animals, everything's made out of carbon. Now, carbon is the backbone of the macromolecules, the big molecules that are kind of like underneath the organelles and things like that. So there are four basic kinds of macromolecules: the proteins, the lipids, that's the fatty stuff, carbohydrates, which, starch. I like mac and cheese. Nucleic acids that make up my DNA. Proteins are like meat. So those are the four basic macromolecules: proteins, lipids, carbohydrates, and nucleic acids. I don't know how to remember that. Plickin, plickin, the plickin macromolecules. I don't know. Anyway, proteins, lipids, carbohydrates, and nucleic acids. And carbon stands at the heart of them. Now, carbon, which you can't see because, there we go, carbon. Carbon wants to have four bonds with something. Now, I don't know whether you need to know this, but a little basic chemistry here, right? So the atom, the atom has orbitals or layers of electrons. The closest layer, where kind of like the hydrogen helium uh, layer of the atom, is just have two little electrons in a sphere. And then so carbon is on the second row of the periodic table, and it's atomic number 6. And so if you ignore the first two electrons, which are in the tiny shell, there are four kind of electrons hanging around in carbon's outer shell. Well, you know the octet rule, right? The octet rule is a atom prefers to have 8 electrons in its outer shell. So carbon only has 4. That leaves 4 kind of hitching stations, 4 places, we can put 4 horses here. There are 4 kind of Lego connections just waiting for to be attached to something. And so carbon attaches stuff to its 4 docking stations, its 4 plug-ins, as it were. And so methane, CH4, is just a nice little molecule. I have a, yeah, there it is, methane. So you've got a carbon and you've got 4 hydrogens on it. And so that's a really nice little molecule because carbon already has 4 electrons in its outer shell, and now it has its 4 docking stations. Click, click, click. You can put 4 hydrogen Legos into it. And so now these are covalent bonds. Now, this is a biology video, so I don't know whether you need to know about covalent bonds, but there are 2 basic kinds of bonds in chemistry. There are ionic bonds, which they kind of hang around each other because of the charge, ions. One's positive, one's negative. Zzz, that's an ionic bond. But in the middle of the periodic table, those atoms tend to, they're more Christian. They share. They're covalent. And so carbon tends to form covalent bonds, where we are one in the bond of covalence. And so covalent bonds are shared bonds. The structure of this is tetrahedral, which is, I think, you got basically, I should have drawn it, but it's like if you, in the stick model, ball and stick model, you've got the central carbon, and you've got the sticks coming out, four sticks, to where you would have a triangle, like four triangles, I think it is, hanging around. Anyway, so it's a tetrahedral kind of structure, but I don't think you need to know that. Okay, so we're getting there, right? So hydrocarbons, as you might expect, are carbons with hydrogens hanging around. So the methane we just saw, that's a hydrocarbon. Hydrocarbon. Okay. Um, Now, a hydrocarbon is only carbons and hydrogens, and this is the stuff that gas, is made out of, and this is the stuff that's, kind of accelerating the warming of the planet, according to most scientists. So, methane is a hydrocarbon, given off by cows, of course. Cows fart a lot of methane. I think, probably if you had a methane detector and you followed me around, you, I don't know. I mean, no, of course not. Anyway, this is a very simple hydrocarbon, with the four hydrogens in its docking station. But you can extend it, right? You can have two carbons. That's ethane. It's a very ethical molecule. There are two of them. So it's monogamous. There's one pair. There's not a menage de trois. It's like propane. That's very unchristian. But ethane, they have two carbons. They stay with each other, and they have six children, six hydrogen children. But anyway, and I didn't draw it, but you have two carbons. One of the bonds is taken up with each other. They share one bond. They had a ring ceremony in their wedding. Anyway, and then the other, kind of the three bonds that are left on each carbon, each have a hydrogen, and so that's ethane. And so you can take this out. So propane gas is used, for example, in our grill, on our deck. And propane has three carbons, and then all the other docking stations are filled up with hydrogens. And you can keep going. Butane is another kind of, we talk about high octane gas. High octane gas would be 8 oct, you know, and so you'd have 8 carbons in octane. So anyway, I don't know that you need to know that for your test, but this is the basic kind of I find it easy to think about this as the starting point of the carbon stuff. Okay, now, okay, there's propane. So propane has 3 carbons, and then all the other docking stations, so each carbon you can see has 4 bonds, you know, everything's filled up. Okay, so there are variations, of course. So there are things called isomers. Iso means same in Greek, so you should know that, Sophie, because you're Greek, right? So an isomer is a you have the same formula but a different structure. So for example, you could have fun here. You could have, not so much with propane, but like, let's say it was C4. You could have let's say it's butane. You could have the nice butane with the 4 carbons in a row, or you could have 4 carbons, as in one of the carbons off here, and might have the same formula, but it would be a different structure because the carbons were arranged differently with branches and things like that. So those are called isomers, where you have the same formula and a different structure. Sometimes you can have rings. Those are called aromatic hydrocarbons. I don't know. Do they smell? I should know this. But like, I think of benzene. In fact, I think I put it on twice here. What was I thinking? Rings. Benzene, C6H6. It's basically six hydrogens in a circle with hydrogens around it. I like benzene, because I don't know, I remember benzene because the government made them take it out of my high school lab. So when I took high school chemistry, they had just forced them to take the benzene out of the chem lab. And you know why they did that? Because it causes cancer. At the time, I thought, stupid government. And now I think, stupid me, because I don't want to get cancer. So, but benzene is a circular kind of hydrocarbon, an aromatic hydrocarbon, benzene. Okay, sometimes you can have double or triple bonds. So, for example, if you take this ethane and instead of having it one bond each, let's say you'd put a double bond between the carbons. Of course, then you would need fewer hydrogens. But basically, there's a system for how you do this. So if you take ethane and you put a double bond in there and decrease the hydrogens accordingly, then it's called ethene. And then if you put a triple bond in there and decrease the hydrogens accordingly, then it's ethyne. I don't know whether you need to know that, but it's easy enough to kind of tuck somewhere in the back of your mind. Now, if carbon and hydrogen are a married couple, then they can have friends over for dinner. Makes no sense at all. But basically, these are the other elements that kind of can bond into the. So a hydrocarbon is just the carbons and the hydrogens. But if they invite friends over, and I tried to think of a way to remember this, like spawn or I don't know, snop, maybe snop. But anyway, I think oxygen and nitrogen are more common, so I put them first. But let's go with snop. Sulfur, phosphorus, nitrogen, oxygen. These are elements that also can join the fun. But we will have no gold coming over, no silver coming over. It's just the snop friends. Okay, so that brings us to probably the most important part of this video, which are what are called functional groups. These are kind of like special attachments. I don't know. You ever have a Mr. Potato Head? Mr. Potato Head had a mustache. He had lips. He had ears. He had shoes and things. But there are attachments, special attachments that you could put in Mr. Potato Head. So there are certain functional groups that can be plugged in to a carbon hydrogen kind of structure. And I've never quite got these down. So maybe as I make this video, I will finally get these down. So I started with methyl. Why? Because we just talked about methane. So basically, if you take a carbon and you put 3 hydrogens around it, but instead of putting the 4th hydrogen on it, which would make it methane, the cow gas, if you base this means this is attached to something. So if you this is called methyl. It's a functional group that plugs into stuff. And it's like methane, but without one of the hydrogens. Instead of the final hydrogen, you plug it into some other group of atoms. Okay, so that's methyl. I thought I'd start with that because it's like methane and it's easy. Second, oh, there it is. So this is going to be attached to something. And then there are the 3 hydrogens. So it's like methane, except instead of the final hydrogen, it's plugged into some other molecule, okay? Some other thing. Okay, I went with the alcohol because alcohol is easy. Rubbing alcohol, um, uh, drinking alcohol, basically OH, a hydroxyl group. And hydroxyl works, right? Hydro for hydrogen, oxyl for oxygen. So it's a hydroxyl. And I think you probably don't have trouble remembering that. So what's next? I think I went to carboxyl. So carboxyl also has, so we had hydroxyl, which was OH. Now we have carboxyl, okay? So the OH is alcohol, hydroxyl, add a kappa, add a C, a carbon, and we've got carboxyl. And so I tried to remember how to remember this. And I thought, chew, if you rearrange it, it's a car box on a choo-choo train. Carboxyl. Da, 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 anyway, choo-choo. Does that help you remember it? We'll see if I remember it. Carboxyl groups go on like acetic acid is a kind of weak acid. And amino acids, which of course are the building blocks of proteins, have carboxyl groups, which doesn't make any sense to me for reasons I'll mention later. But anyway, it is what it is. This is the choo choo carboxyl. Okay, okay, carbonyl groups. Ooh, uh, I didn't make it unfold in a nice way. It's now fixed. So carboxyl, choo choo, carbonyl, um, Bono is in a band. Um, so anyway, there are two configurations of this carbonyl. I'm going to think of this as the carband. I don't know if it helps. The carbond, carban. Anyway, carboxyl is chew. Carbonyl is co. Okay, let me come up with something here. So the problem is that so the carbon has two other bonds, and there's two ways to do it. So if this co is stuck in the middle, then it's a ketone co. I'm trying here. Ketone. The ketone is co. Anyway, so if it has stuff on the one bond and stuff on the other bond, then it's a ketone. Okay. Now, if it has a H on one side, then so like it's got stuff over here, but it has a hydrogen on the other bond, then it's an aldehyde. So here's what I've tried to come up with: aldehyde and the ketones, and his double carbon. Aldehyde and his ketone in the double carbon. I don't know if that helps. Anyway, aldehyde is he has an H. He's aldehyde. Okay, aldehyde, and he's in the carband, carbonyl, and then he's got a double bond, so it's a double carbond. It's a double carband. There are two cars in the band. I don't know. Is this helping at all? Aldehyde has an H in a carbonyl group. Ketone is in the middle, and the ketone is co. Anyway, I don't know. Maybe I should come up with something better. I challenge you to come up with something better. But aldehyde has an H in him, and he's in the carband. And the ketone of the carband is co. Anyway, I don't know if that helps. Co is the ketone. Anyway, aldehyde. From formaldehyde. Do you know formaldehyde? It's what they. I had to dissect a fetal pig in my biology class, and it smelled awful. And because it was in formaldehyde, so this smells really bad. But you could say aldehyde smells bad, and he's got an H in it, and he's in a band, but he smells bad. I don't know if that helps at all. So ketone is co, and aldehyde smells really bad, and he's in a carband, carbonyl. I don't know. Try it. Okay, this is amino. This is amino nitrogen. He's amino nitrogen. So NH2, there's going to be something over here. He's amino, and amines, by the way, are what are built out of this. So this is the amino group, and it's going to be attached to stuff, and he's aminoed nitrogen. Okay, nitrogen takes 3 bonds, apparently, and so there's going to be something over here, and then the other 2 are taken up with hydrogens. Okay, phosphates. Oh, poo. Phosphates are poo. And they tend to be -2, so there's going to be something attached here. I give them a -2, and they're poo. It's double poo, so it's got a double bond on one of the oxygens. So it's double poo. It's a phosphate. I don't know if that helps. Lastly, we have sulfhydryl, which is pretty easy to understand because we've got sulfur and we've got hydrogen. Got a sulfur, got a hydrogen. Shh, don't tell anybody, especially thiols. I don't know who thiols is, but that's what you call these sorts of sulfhydryl compounds. But shh, don't tell anybody. Well, I've done my best to try to come up with stupid stuff to help you remember the functional groups. See if you can do better.